Okay, for Civil 3D Lab 4, similar to Lab 3, you're going to first want to open up the Civil 3D metric. So you have to do that by going to your main apps menu and finding it. It's going to look a little different on the lab computers than my office computer. But you want to make sure that you select this Civil 3D 2017 metric. And we're going to be using the same drawing that we used in the last lab, which was defined in metric units. So be sure to open up the metric program first and then go ahead and find that copied Civil 3D Lab 4 subfolder within your own personal folder, and when you open it then you'll see a file similar to what you would have ended with at the end of Lab 3. So for Civil 3D Lab 4, we're going to be working in the same drawing that we've been using for several labs, where we're looking at the subdivision, and it has the horizontal alignment for First Street and Second Street defined. But this First Street alignment, what we did in the last lab is we created the proposed ground profile, the blue profile. We defined corridors, sample lines, and generated earthwork, and defined these assemblies. So with this lab, we're just picking up where we left off with that. So you'll see all those pieces in it. You'll also notice, this kind of came up a lot with the project, because we use criteria-based design for the profile. If I'm going to select that profile and bring up the grid view, we get a fair amount of errors dealing with passing sight distance, headlight sight distance. In some cases in your project you might also get drainage. Since this isn't a class in roadway design where we're going to go through all these, in this lab we're going to show how we can kind of ignore some of these exclamation points or warning errors and get rid of those. But the main product from today's lab is to learn how to generate plan and profile sheets from a design. Okay, so this is questions come up a lot about these exclamation points, and as I mentioned earlier, since we're not too concerned about the roadway design part of them, and we want to focus more on the geomatics or the surveying part, we're going to go ahead and turn off these notifications. So how you do that is you go over to the prospector menu, and under alignments, if I click on center line alignments, I see that this drawing has two alignments, the First Street and the Second Street, defined. And by drilling down deeper, I go under profiles and I see the two profiles that I have defined, the surface profile and the proposed ground profile. And where this criteria-based design, we defined it right at the beginning when we were doing the create profile. But I can also get back to that information if I go and right-click on hit properties for the proposed grade, and I go to the design criteria. And if I deselect this, it will no longer use criteria-based design. And I hit OK, and you'll see that all those exclamations. So it's no longer checking to see if we have minimum curves. So at this point, I could make a change, and it would never go through to see whether it was the adequate curve length or not. So we want to kind of wait till the end to do that. Another thing you don't have to do at this point, but I did want to point out, so when we use criteria-based design, it's using a design speed. And sometimes after designing the road, you see that it really doesn't function very well at that speed, and you may want to go back and make a change to that design speed. So to do that, you'd go back to the alignment itself, because remember we designed the speed when we designed the horizontal alignment. So under First Street properties, you'll see that it has this 40 kilometers per hour design speed associated with it. This is also where we could add different ones. So maybe a portion of the road was designed at 40 miles per hour, or 40 kilometers per hour, sorry, and maybe further down the geometry either straightened out or got even curvier, and we might want to change the design speed to something else, and we would be able to add it, and we'd set what station that started at, and then we could use different design criteria for it. And as I mentioned, that once you get into the junior class where it's all about roadway design, we'll spend more time looking at that. But I could go in here, like I said, and change it. And so this box for using criteria-based design is associated with the horizontal alignment, and what we changed earlier under the profiles was dealing with the vertical alignment. So kind of two separate areas. So I'm going to go ahead and hit that, and you see that those exclamation points go away. So the next step of the tutorial is to define the view frames. So far we've been working on the overall project. So when I look at the horizontal alignment, I see everything for First Street. I even see Second Street. I see the entire profile. When we want to go down to the plan production stage, we're going to need to split up this alignment into smaller sections so that they can fit on a standard plan and profile sheet. So similar to what you saw at the beginning of our Civil3D where you looked at those Yesler terrace plans. So we would see some overall views of the project on the initial sheets or the reference only sheets, and then when it got down to the actual sort of design details or the part that the contractor was responsible for, we would see only sometimes 300 or 400 feet of the project at a time with the plan view and the profile view. So that's what we want to start working on as we wrap up our Civil3D. So for the first time, instead of using the home menu, we want to go over here to this output menu. So this is the first time we're going to see this ribbon. And this is what we control the outputs. This is where if we were going ahead and printing or plotting, we would be using some of these tools. But way over to the left, under this Plan Production panel, we see Create View Frames. And we'll go through this. So it'll lead us through a wizard. So the first thing it'll ask us is which alignment that we want to create these view frames for. So in our case, we have First Street and Second Street. So we want to be selecting the First Street. We're going to go ahead and use an automatic station range where it's going to use the start and end station. If I wanted to use user specified, I could kind of define a sub area from that. I want to go ahead and hit next. This is where it's asking us exactly what kind of plan sheets or plans we want to create. So the options are plan and profile, where we get both the horizontal and the vertical alignment. I could select plan only, where I'm only going to see the horizontal, or profile only, where I'm going to only see the vertical. In most cases, the most common is to do plan and profile, but there's some, especially for route surveying type projects, long linear projects. When you get into building plans and other types of projects, you may start to see like plan only or profile only. The next thing is it's asking is how those frames are going to be placed. So the most common one is to do along the alignment. And so what it's going to do is it's going to rotate these view frames. So these orange rectangles are what we're creating with this step. And so for the most part, we want our north to be up, but we also want to be efficient. We want to get the most linear feet of project to be shown each time, and that's going to happen if we kind of follow it. If we rotate everything and we force it to have north be strictly up, you can see how it kind of rotates the view frames, and it keeps it so that north is always straight up. But as I said, we want north to generally be up, but we also want to be efficient with the number of sheets that we have. So this is probably the most typical way that plans are defined. So I'll hit next. Now it's asking how things are going to be labeled. So it's going to, each view frame group, or VFG, it's going to be called VFG hyphen, then it's going to use the alignment name, so in this case First Street, and then it's going to use a counter. So VFG First Street 1, 2, 3, however many view frames it needs to create. So most of the cases, like a lot of the wizards, we're going to go ahead with all the defaults. The same thing here, we want to look at this a little bit, is match lines. Now remember, when we create plan views or plan and profiles, anything that's part of the construction bid documents, these are sort of legal documents that the contractor has agreed to construct exactly as shown. And one of the things that we want to do is we want to make it very clear what the contractor is responsible for paying for constructing. So we don't want information to show up on more than one plan set, one plan sheet. So think back to the Yesler Terrace project that we were looking at. It was very clear at the beginning that those reference sheets, those overall sheets, were just to get an orientation of the project. But once you got into the construction bid part of it, the plan and profile sheets, that a particular element, say storm sewer manhole or curb inlet, would only be shown on that one set of plans for grading or for paving. And so how this is done is by using match lines. And match lines kind of create a hard line where one sheet is going to end and the other is going to begin. And if I kind of go back here and I look at these view frames, you can see there's overlapping. So in this area or this triangle, if I didn't use match lines, it's possible that a feature like a manhole could be shown on two sets of plans. Defining match lines forces that particular ground to only be shown on one plan sheet or the other. So what it's asking here is where that match line should be, and we typically try to use a rounded number. And so this is what it's asking by saying snap station value down to the nearest. And if I leave it at 1, it will force the match line to happen at an even 1 foot station. So I think in your directions, I talk about an example of, for example, the match line might fall on station 15 plus 83.15. And we don't want to leave it at such a sort of unrounded number. It just, becomes complicated to look at, So if I said this, if I left it at 1, it would force it to be rounded, so the match line would then happen at the nearest whole integer, or 15 plus 83. If I changed it to 50, it would force it to be it would round down to the closest half station, or 15 plus 50. If I set it to 100, it would round it down to the nearest full station. So similar to what I was talking about with the rotating north, we want to make a trade-off between being really easy to read for people looking at the plan sets, so even stations would work well for that, versus not having too many sheets. There's production costs, but also they just become sort of cumbersome to carry around the construction site. So you definitely want to do rounding. I would say probably the most common is probably to round to 10, but we're going to go ahead and leave it at 1. So this is just asking which layer we want the match line to be, and it's going to use a match line counter, right, for every page, where it's going to just call it match line 1, 2, etc. So we want to go to this. The next one is it's asking how we want our profile and plan sheets to look. This is something that agencies usually have default files for. In this case, we're going to use just the ones coming from Autodesk. So the last part is just create view frames. We'll select this, and we'll see these blue lines show up. Right? And so it's saying that for this project, we'll be able to get everything onto 2 plan sheets. So if I look at it, I see view frame 1. And down here, I'll see view frame 2. And then this is the match line. So we forced the match line to be at an even station. So it happens, it's going to use plus 267. And so information on this side of the match line will show up on the first sheet, and the information on this side will show up on the second sheet. And so even though we have this overlapping part where we see these 2 different frames, that information will only be shown on one plan sheet. So these view frames are Civil3D objects. So if I select on them, I can get a menu where I can go through and edit if I wanted to change some of the properties, or if I wanted to change some of the definitions of how match lines or the view frames are oriented. I would be able to go up here and edit them. Okay, so the next step is to use these view frames to create the plan and profile sheets. So up in the Output tab on the Output ribbon, last time we used this Create View Frames. Now we're going to do Create Sheets. So it's going to use these view frames to create the plan and profile sheets that we defined. So it goes through a wizard. Like most of these, we're going to accept a lot of the defaults, but there's a couple things that I wanted to point out. First, it's going to ask which view frame group that we're using. So we only define them for First Street, but you can imagine if you had multiple alignments that you might be creating them using the different view frame groups. We're going to go ahead and leave it as all. So we want to create plan and profile sheets from every view frame group, but we could also do a selection where we did a subset of it, and it would tell us which one. So number of layouts per new drawing, so we're going to put 1 per drawing, and it's just going to name them sheet 1 through whatever, up to however many we specify. So we can pick a north arrow, so it's going to put a north arrow in all of these. And then we'll hit next. Now it's just asking for the sheet set. So we're going to go ahead and create these new sheets in a new drawing. That's the default position. We could also add them if we wanted to add to different sheet sets. And it's just asking where we're going to put them. It's going to default to the location where this current drawing is located, but just verify that it's going to your subfolder. It's asking for different views. So like if you were in a consulting company, you might have different ones defined depending on which client you're working with, but for the most part we're just going to use the default ones that come with the software. And then align views, so align the plan and profile view at the start or at the center or at the end. So it's saying it's going to stack the horizontal and vertical alignments together, and it's just asking at what point should they be matched, because they're obviously going to be different lengths, right? One is following in a horizontal plane, the other in a vertical plane, so they're not going to be exactly the right, and you can force it to sort of be the exact match in the middle or at the end, but the most common one is to match them at the start. And then the next part is data references, and this is where Civil3D objects can be shared between drawings. For what we're doing in this class is not important, but when you go to take a sort of either the junior class or certainly if you take the elective class, we start referencing lots of different drawings, and in some cases we want the alignments to be available to be used in another drawing, and this is where we would set that. I guess I do want to go back and look at one thing back here in this layout creation. Number of layouts per new drawing. I want to set that to 10, and what it does is it creates a single drawing where it's going to put a different layout per sheet, but that drawing is going to have multiple sheets, and we're going to let it be up to 10. For this case, it really is only going to create 2 sheets because we have 2 view frames, but this is a number that you'll want to think about for your project, because you want it to output to a single drawing. Now, in the case of like working on a real project with consulting firms or for the agencies, sometimes you want this number to be a lot smaller because you might have a whole team of people working on it, and if you can parse it out to different drawings, then people can be working on different things at the same time and not be overriding each other. So go ahead and hit create sheets. This is what we would have gotten to at the end. And it's always going to ask, it needs the drawing to be saved, because remember, anytime we're up here in our drawing and we have an asterisk, it means we've done something that hasn't been saved. It always wants to save it this, so go ahead and hit OK and let it process. It's going to ask for the origin, profile view origin. So hit a blank spot and then let it go ahead and process. So at the end of it, you'll see it'll come up with a sheet set manager. So it's saying for the view frame group of First Street, it has 1 drawing. It's all been put under this. It'll go up to 10. If you had a really long alignment that had more than that number that we set for the number of views per drawing, you would see multiple drawings here, and then you would see 1 up to 10, and then it would be a VFG First Street 2 drawing, and then up to 10 more sheets, and etc. until it created enough space for all these view frames. So the next thing we want to do is go view the sheet sets that we just created with this step. So we've been looking at this sheet set manager, which shows us how the different sheets that it creates are divided between the drawings. So in this case, we only had 2 sheets, and we were allowing up to 10 sheets per drawing. So we see only 1 drawing created. But if we had, say, 20 different sheets, we'd see 10 of them in one drawing, and then another drawing name listed and the remaining 10 shown. So with this, I can close this. If for some reason I close the manager and I want to see it again, I can type in sheet set and it brings up that manager. But for now, let's go ahead and open. I can go to the Start menu, or I can go up here to Open, and I want to open that drawing. So by having that manager, I can see that the sheet that I want is in this drawing, and I open this up. So a couple of things. I'm going to go back to Lab 4 and get rid of this. There's some tabs down here that we haven't done anything with in the previous labs, but I wanted to point them out, and they have some parallels to what we saw in GIS. And we've been working in model view, and so model view is where the data is contained. I see all my alignments and whatnot, and then there are layout views. And Civil3D always kind of creates these paper views similar to GIS, where it puts some of the information on them. In most cases, unless you go and configure these, they're not going to be very useful. They're going to be kind of jumbled and not arranged very well. But I can quickly, if I wanted to do some quick printouts of different pieces of the design, I can change the scale. I could add some legends, scale bars, all those types of things. But for the most place, when we're designing in our design drawing, we're going to be in model view. Well, when I go to the new drawing that was created that holds all these plan and profile sheets, you see that it defaults to a sheet view. And it's going to have one tab for every sheet that gets created. It also has a model view. In this case, it's not showing anything, but if I zoom extents, you'll see that I have all the information that was in my model view of my original drawing. But what's different is that all of this is just an object, right? I can't go and edit. I don't have any access to making changes to it. Depending on how I defined it, I usually can go and see information about the Civil3D objects, but these objects actually are defined and live in this original drawing, and they're just here for information purposes. So if I go back to this, it does have some new objects here, and these are the two profile sheets that were created for this. And so if I have issues with scale, or if I want to make edits to the way these profile views, right, it took this main profile and it split it up according to where I was at, I would go to here. But first, let's go and look at these sheets. So the sheets will always be starting in direction of increasing stations. So I see that station 0 is here, and it's going to be matched up exactly even with station 0 on my profile. That's because of that setting where I wanted it to align on the left. It also will have some information about the scale bar and the north arrow, right? And so it's using match lines. So it's exactly matching on an even 1 foot station, and both the plan view and the profile view would be cut off at those. And then if I go to sheet 2, I would have a match line that exactly matches up, right? And so it masks out all this information so that information on the plan view that falls into this area would be shown on the previous plan. And so we wouldn't get duplicate information. So in civil engineering plan production, you can spend a lot of time working on these different sheets and adding all the annotation that the contractor is going to need for building your project and all that. In this class, we're going to take a pretty simple view of it and try to just show some basic information about the plan and profile. There's a couple of things, though, I did want to point out. So as I mentioned before, so we're in this view frame group drawing, and most of it is just referenced information from the Lab 4 drawing, but there's these two profiles down here that are used in the profile views. And so in this case, you're seeing that is kind of cutting off some of the information, and in this case it's cutting off quite a lot of the profile information. So sometimes you need to go in and make changes to these. So these are defined as civil engineering objects over in the prospector menu, and if I look at centerline alignments, First Street, most of the time when we've been making changes with our profiles, we've been up here in this profile section, but when we want to make changes to how the profiles are viewed, we go to this profile view, and if I see if I can extend this out, you'll see that I have a sheet 1 and sheet 2, and so this is sheet 1 profile, sheet 2 profile. So if I go to properties, it has information about what these profiles actually look like. Usually the case has to do with this elevation range. So in this case, it's not giving me enough height, and then so it's cutting it off. It shows that it should be showing elevations from 32 feet up to 47, but it's just one of those things that sometimes when it creates, it actually isn't. It's only showing me a little above 40. So I'm going to go ahead and kind of increase this height and see if we can. That didn't work. I was dealing with the profile 1. I want to change for profile 2. I'm going to go ahead and increase that height and see. That's again not getting enough. The other thing that I can do is I can change the actual vertical exaggeration. So I talked about this in class about how we sometimes show our vertical scale in a different setting than our horizontal in order to exaggerate sort of the verticalness of it. This is a project that happens to have a fair amount of vertical, so if I wanted to change that vertical exaggeration, I would go to this edit. So I'm under the First Street, and I want to change the exaggeration to 5, meaning I'm only going to exaggerate vertical distances 5 times as much compared to horizontal, as opposed to this what it was set at 10. And so if I hit apply and OK, you'll see that it kind of compresses those down. So they're going to take up less space. And then now let's see if I can get this elevation to show more. So it kind of increased a little bit. There's only a certain amount that it'll be willing to show because it only has so much space in the drawing itself. And so I'm going to go a little bit more and change it. I forgot to hit apply. So now I can see the entire profile. And then if I do the same for First Street 1, I should be able to adjust it so that I can see the whole thing. The other thing that I want to do for the project is, you see a lot of times if I'm looking at it, my labels are extended so far up that I don't get to see them on my plan sheet. So I can grab them and kind of bring them down. This one is a large profile that's going off of my drawing. And I can work on, sometimes the beginning and ending ones are a little bit strange. But now when I look at my sheets, I should be able to see more information about my vertical curves. So I can see, the different lengths of the vertical curves are now going to show up on the drawing. So as I mentioned before, probably 30-40% of your time on plan production is actually spent after you've already designed it, and you're trying to clearly show to the contractor all the various pieces. In this class, we're going to not spend too much time on it. But one last thing that I wanted to do that you're going to have to do on your project as well is get rid of some of this additional information. So if I go and I look at what's showing up on my plan view. I still have these sample lines, and the sample lines were important for us to calculate earthwork, but they don't have any meaning to the contractor. They're not something that he's going to be building. And this is a good opportunity to talk about layers a little bit more. So if I go back to the model view and I go sort of back to my home tab, I can look at this layer properties. So it's over on home tab and layers, and it brings up all the layers that my drawing has defined in it. So this is something that different consulting firms and agencies use some pretty strict like templates within their office so that people working on the same project don't have to try to understand, you know, what's going on in it. But if I look at all this, I can see the various layers, and I'm going to expand out a little bit. So most of the time these are the default layers that Civil3D uses, but like I said, if you work for different agencies, they'll have their own convention. But most of them use, you know, pretty standard, or you know, sort of things you can sort of deduce what's happening. But there's lots of things about the roads, the storm sewers, water lines, topos, and whatnot. And you'll see that as you scroll down, that you begin to have layers that have this convention Lab 4 with this pipe or vertical line. And these are XREFed, meaning that these are objects that are not in the drawing itself, but are in the drawing, the original drawing, this Lab 4. So if I wanted to remove the sample lines aren't in this view or the sheet file, but they're back in Lab 4. So I would have to go and find, it's under road and it's under sample, and there's both the sample lines and then the sample text, which are the labels that are on the end of each sample line. So there's two different things I could do. The first one is I can turn a layer on and off. Usually we use things on and off if you know, we want to temporarily sort of remove them from the view, but we likely want to turn them back on at some later part. The other one is this freeze, so it looks like a sun, and if I hit it, it turns to a snowflake. So if there's something that I never want to show up in the drawing, so in this case the planned production, I want to go ahead and freeze it as opposed to just turning it off, right? So if I then go and do that and I look at my drawings, you'll see that I no longer have those showing up. So sometimes I have things that I don't know the name. In that case, I knew that they were sample lines and I could find them. A command that I can type is xlist, X, so standing for X reference list. So tell me, you know, what is in there. So in this case, I see that I have, you know, it's telling me it has an object, which is a station label, and then it's giving me, this is on the C road text. So I can sometimes see if there's an object that I can turn off. So I don't want to turn off my labels because that's where all my station labels are. But if I I'm trying to look and see what this purple line is, and it looks like it's a road corridor. So it's under Lab 4 C road corridor. I can see if this is something that I can turn off and won't lose too much information. C road corridor, I might just turn it off just to see if it's going to get rid of what I want. Doesn't look like that was the right layer. But anyway, going back and forth between, you know, seeing if some of these layers can be removed. It's hard because they're always on top of each other. Lab 4 C road corridor. Yeah, so it looks like those magenta lines are something that can't be removed. But anyway, so we got rid of the sample lines, and that kind of cleaned up our document a little bit. So now we can see that we have plan and profiles that are in kind of reasonably good shape. And we're going to leave it there, and then the next step is I'll show you how to plot them out to a PDF. One last thing that we're going to do to our plan set before we plot it out is just put a little bit of information down in here. So I could, each of these, if I go and zoom in on my sheet view, I can see that I have this sort of dynamic text. So I might want to say the project name is the Civil3D Final Project. And I might want to put my name. And so I'd like you to do this for your project, just so that as I'm looking at everybody's drawings, I can see things that are different. So make sure that you have that it's the Civil3D Final Project and your name. And you want to Civil 3D so they get that looking reasonably well before we plot it. So batch plotting is a term for when you want to create output, whether it's to paper or to a file, for multiple sheets at the same time. So instead of going one sheet at a time and plotting it, you're going to do it in a single batch. So this is done under the output menu, and so plot would be just doing one sheet at a time, one file at a time, and then there's this option of batch plot. So if I select that and let it come up. So this is particularly useful if you have lots of different sheets and single drawings, but also if you have multiple drawings. So think of that Yesler plan set where it had lots and lots of different sheets. That would have been done, and it's sort of dozens of different drawings. And batch plot is a way that you can publish all these and sort of package them all at the same time. So in this class, everything that we're going to be doing is we're going to publish to PDF. So we're not going to actually publish to paper, but we're going to just publish so that it'll put all of these into the same PDF file. Okay, so on the batch plot menu, we want to, it'll be set to this plotter, so you can define a plotter that you would use for your project, but for this we're going to publish to PDF. Under the PDF presets, there's some general ones. If you're going to publish this PDF to a mobile or web device, you want it to be small, and resolution is limited by your screen resolution. And then the other ones, so general documentation is what we want, but if we were publishing to high quality, like sending it to the printer for large-scale plotting, or smallest file if we were worried about the overall size of it. But as I said, we'll use general documentation. So it's set here to automatically open all load all open drawings. And so because we had Lab 4 and this VFG, it's seeing both of those files. And so we see both the model view from both of those. And then we have these layout or the tabs. So every tab that we have on those open drawings show up in here. And so for what we want, all we care about is the sheet 1 and sheet 2, which are the two plan and profiles. For your project, you'll have more than these. So if we're seeing something, a sheet name that we don't want to be part of our PDF, we would highlight it and hit the negative. So we're going to go ahead and leave only the sheet 1 and sheet 2. If I wanted to add a sheet for a drawing that wasn't open, I could hit plus. If I needed to change the order of it, I could highlight and hit these up and down arrows. This might come into play for your project because if you have more than 10 sheets, sometimes it puts the 10 underneath the 1 because it does it by alphabetical order in a lot of cases. So anyway, that's the one case I've seen where you've really changed with this. It's showing where the drawing is located. It's going to ask you later where to save for the PDF. But we're going to go ahead and hit publish. It'll go through this. So it's asking, okay, where does this PDF get saved to? I want to go put it in my folder. So I'm just going to go ahead and call it Lab 4. And this is asking whether we want to save the current list of sheets. So, you know, how these things are ordered and which drawings they come from. So for ours, we don't need to because it's 2 sheets. But you can imagine for like a plan set like that Yesler Terrace that we looked at a few weeks ago, where it has so many sheets that quite a bit of work would have gone into getting them exactly ordered. So in that case, you would say yes, and it would remember all that information. And I'll go ahead and hit publish. Now, the process for publishing to PDF or for printing is pretty time consuming, and you're going to see how long it takes just for these 2 sheets, and that'll give you an idea about how long it's going to take for your project. So as it's going through and publishing, if I see down here, you might get a pop-up box that says that you're publishing in the background, and I have that option turned off for me. But if I go down here to this bottom, it'll show me the published job is in progress. And when it's complete and the PDF has been fully written to, you'll see a pop-up kind of message come up here saying that it's complete and you can go look at it. So just because it takes a long time, we'll stop the video here, but you'll see how long it takes. And once it's done, you can use your File Explorer and go ahead and open it and see the PDF file that it creates.